Welcome to Physics Around Us. Today, we're exploring the incredible impact of Newton's laws of motion across our universe and in our everyday activities. First, let's venture into space. According to Newton's first law of motion, objects in motion stay in motion unless acted upon by an external force. This principle explains why a spacecraft, once propelled, continues to travel through space at a constant velocity until other forces like thrusters or gravitational pull act upon it. Back on Earth, this law plays out in simpler scenarios too. A table tennis ball at rest remains still until struck by a paddle. The ball then moves in response to the force applied, perfectly illustrating that objects at rest need an external force to set them into motion. Now, Newton's second law comes into play. When lifting weights, the acceleration with which you can lift them depends on the force you apply. Heavier weights require more force for the same acceleration. This law tells us that force is the product of mass and acceleration, guiding how we manage weights and movements. While enjoying a boat ride, every stroke of the oars demonstrates Newton's third law. As you push the water backwards with the oars, the boat moves forward. This action and reaction are equal and opposite, propelling the boat through the water. The fun action of bouncing on a trampoline also illustrates this third law. When you jump, your weight pushes down on the trampoline. The trampoline fabric stretches and then pushes back, propelling you upwards with an equal and opposite force. In our toolboxes, the principles of physics are ever present. The wedge shape of a knife or a nail concentrates force onto a smaller surface area, making it easier to cut or penetrate objects. These simple machines multiply the force we apply, showing physics at work in mundane tasks. Consider turning a bicycle or an airplane banking in flight. When you lean into a turn on a bicycle, you're balancing forces, including gravity and a pseudo-force called centrifugal force, which appears in this rotating frame of reference. Similarly, as an airplane banks, passengers feel pushed against the side due to this same force. Even the Earth itself showcases these laws. The rotation of Earth affects ocean currents and tides through the Coriolis effect, a manifestation of forces acting in a rotating system. What seems a calm ocean current is actually a powerful demonstration of Newton's laws on a planetary scale. From the depths of space to the toys in our backyards, Newton's laws of motion not only explain but also predict the natural order of our universe. These laws allow us to see beyond the surface into the fundamentals that govern motion and forces.